All right, lesson 3 warm-up, page 1 for section 911, and we're going to add some quadratic word problems that are not in the book, so make sure you cover the whole lesson and understand from your instructor what's expected for the information for this section, okay? This is what's going to take you through the homework, hopefully. All right, so the warm-up, it says state the range of each graph. Remember the domain and range of a line on the graph. The range is relevant to this section. So what does the range have to do with? Domain really is the kind of the range of the x values. So the range is, in this case, specifically about the y values. So the lowest y is this point right here. That ordered pair is 2 and -4. Remember how that works? The x and then comma the y always. So you go over to 2, go down to -4. That is the ordered pair from that point. And then this point right here would be 4, 1. So the range would be talking about the 1 and the -4. So the lowest y that we have is exactly on the -4. The greatest, the highest y is a 1, right on the 1, okay? And then this one, the lowest y is -1, -3. Right there is the highest y. Think about it. This one's only a -1, but this one up here, this is 1, 1. So the y of this one is a +1. So the lowest y always goes first, which is -3, and then the highest or largest y goes second, and they're hard brackets because they're right on those numbers. Soft brackets mean they go up to that number. Let's go with, I meant that to be hard numbers, so let's put that in there like that. All right. Students will be able to solve and graph applications for quadratic equations. That's what this whole thing's about, and I want to start with finding the minimum and maximum values of a quadratic equation. Minimum and maximum, that does have to do with the range, okay? What's the highest y you're going to get? What's the lowest y you're going to get? That kind of thing, okay? So the graph of a quadratic equation in standard form, right? We've got that ax squared, then bx plus c. And remember the function notation here. That's the same as kind of y. You can think of that as a y. If x is this, what is y? And when you graph a quadratic versus a linear function makes a line when you graph it. A quadratic function makes a parabola when you graph it. It's kind of a U-shaped. To exaggerate a little, it's not a perfect U. It kind of goes like this, and it's a soft bottom. It can also look like that. Okay. The highest or lowest point versus highest point is called the vertex. Okay, the vertex can be found using the formula -b/2a. Remember, that's the front of the quadratic formula. That's where that's from. So that's easy to remember. The parabola goes on indefinitely in two directions, up or down, each moving away and out from an unseen vertical line going through the middle, called the axis of symmetry. Okay. Parabolas have a domain. They all have the same domain. Because they continually get wider in each direction, your x-axis infinitely is covered, so it keeps going out and out as it goes away. But the range stops at the y value of the vertex. So this is a min and this is a max. So if the parabola opens upward, okay, that's going to happen when this A right here is greater than 0. So if you want to, you can write down that it's a positive number. If it's greater than 0, it's going to open upward. And if it opens upward, you're going to have a minimum. That's how that works, okay? If A is positive, this is going to open upward. This is going to have a vertex down here, and the y of the vertex is going to be considered the minimum, okay? And if it opens downward, it's going to have an A that is negative, okay? It's going to go like this. It's going to have a vertex, and the y of the vertex is going to be considered its maximum. The axis of symmetry goes in here. It's going to open up infinitely. Another point on here is going to be exactly across from another point over here, exactly the same distance from the axis of symmetry, okay? And this y is going to be your max or y value, and also the number in the range, right? If it's the highest y or the lowest y. And we don't talk about the domain very much because all of them are going to be negative infinity, comma, positive infinity with soft brackets, because you can't pinpoint where, infinity goes on forever. Okay? So, to find the minimum or maximum in the following real-life situations, we want to process the quadratics, recognizing some things we know about all quadratic equations, okay? So number 1 says the cost of manufacturing bicycles at a production plant is given by the following function. This is called a function and not an equation because it has this notation, it has function notation in the front of it, okay? That talks about when the cost, C, is given per bicycle, which is the X. So this is the function notation for figuring out when the number of bicycles are made, what the cost is of those bicycles. And this is the function that we're looking at right here. And it is in the proper order, 2x squared minus 800x plus 92,000, okay? And we want to talk about the fact that the A is a positive 2. Since the A is a positive 2, it's greater than 0, so it's a positive 2. That means the parabola opens up, which means it has a minimum. It opens up. So this right here, the y part of the vertex, is the minimum, okay? And it says, find the number of bicycles that must be manufactured to minimize cost. So we're always remembering the Vertex Formula, which is here. So it's always good to write it down, negative b over 2a. And when b itself is negative, so it's going to be a double negative, which is a positive 800 divided by 2a, and a is a 2. So positive 800 divided by 4 is 200. So we have... Write it down another step if you need to before, is 200. So apparently we need to make exactly 200 bicycles to minimize cost. Well, what is that cost? What would be the cost for that number of bicycles? So what we need to do, that's code for putting in a x. We just found x. So x is 200. So substitute 200 in for your x to find the total cost, okay? Substitute the 200 in for every place there's an x. So 2 times x squared, or 2 times 200 squared, okay, is 40,000. And then negative 800 times 200 plus the 92,000. And that's going to give you a C of 200 equals 12,000. So the cost of manufacturing 200 bicycles is 12,000. So that means the vertex, if you had to graph it, the parabola would have a vertex of x and y being 200, 12,000. And if it looked like this, the lowest point, or the minimum, would be the 12,000, and then it would go up forever. So that's the range. Okay? So I want to go to the next page and keep going with that because this is still on minimum and maximum. So the business club wants to sell calendars to raise money. The profit from selling calendars is given by the following equation right here. It's a quadratic because it has an x squared in it as a term. One of the terms is raised to the second power. It's not in the proper order that I want to think about my ABC, so I'm going to turn it around. Notice that the negative stays with the x squared. So this is negative x squared plus, add that plus, 360x, and then there's no c, so if you want to put in a 0, feel free to put in a 0. So x is the number of calendars and sold, and p is the total profit from selling that number of calendars. So when we turn it around, our a is a -1, our b is 360, our c is 0 if we want to think about it that way, but for our vertex we don't need the c. Since the a is a -1, the a is less than 0, therefore the parabola opens down, okay, and has a maximum y value, okay? So let's use the vertex formula to find it. So that's negative b, so if b is a positive 360, that's minus in front of there. And then the a, 2 times a is a -1, so a negative 360 over a -2 is going to give you a positive 180. So apparently 180 calendars is what we need to sell. They need to sell to maximize their profits. All right. To find out what the profits would be, find the profit, we need to substitute in that 180 everywhere there's an x. Don't forget to put it in parentheses. The square, that negative is not squared, so 180 squared times the -1 gives you this, and then the 360 times the 180 gives you that, and when you add them together or you subtract them, however you want to say that, you're going to get $32,400. So the profit from selling 180 calendars would be that. If you had to graph it, your vertex of your parabola would have an x value, so that's the first one, of 180, and that's the y value. Therefore, if it was upside down, look at this here, if it was upside down, the range would be negative infinity. It would go down and as it went out, right? And then its maximum it would ever be would be that. Okay? So let's do a couple more of these. All right, so the boy tosses a coin into the air straight up. So sometimes it helps to draw a little picture. All right, he's going to throw something up, and it says the height of the coin above their head is this function, where t is the amount of seconds after the toss. So instead of x, you have a t, okay? Instead of y, you have a f of t. That's the function notation they're using for this one. They want to know how high the coin goes, so think about it. It's going to go up, and then it's going to come back down. So it's going to have a maximum. If you put the function in order, in the proper order, it would be negative 16t squared plus 32t. So your a is a negative, which means you have a parabola that has a maximum, right? That is a is less than 0, therefore it opens down and it has a maximum, okay? And b equals 32. So I want to find the vertex, which is the vertex formula, negative b over 2a. So negative 32 over 2 times a negative 16 is a negative 32 over negative 32, which is a 1. So it takes 1 second for this coin to go from here up to here, okay? 1 second. All right, and then it wants to know how high, let's see, how high it goes and how long does it take to get there. So it's going to probably ask you both most of the time. You have to, it doesn't really matter which one it asks you first. You're going to have to find the x value first. So in this case, consider this x value a t for time, and this is 1 second. Okay, as a habit, I write the x in the formula, but it's really talking about a t in this case. So my t, in fact, the vertex is going to be t and f of t. Okay, that's the vertex. It's not really an x, y in this case. It's really a t and an f of t. So to find out how high it goes, I need to use that 1. I need to find the f of 1 in the formula. So I need to substitute that 1 in the formula. So this is 1 squared is 1 times that is negative 16 plus 32. So f of 1 equals, equals 16 feet. All right, so in max height, this boy is going to toss the coin. When he lets it go above his head, it's going to go up 16 feet in a second and then come back down. So the vertex is 116. So how high does it go? 16 feet. Okay, and how long does it take to get there? 1 second. So it's going to go up 1 second and come down another second. So it's going to take 2 seconds to get back to his head. Okay, so that's how that one works. All right, I'm going to have to do some more on another video. This one's taking a while. Okay, so try the next two.